This video shows how to draw the Lewis dot diagrams for covalent bonds. I would say this is the easy method, and what I'm going to demonstrate will not necessarily work for a more complex molecule, but for all the ones we'll see in class, this will work. So, first of all, we know that we're going to be making a covalent bond because all of the atoms we'll be working with are nonmetals. So they all have a very, or at least moderately high electronegativity. They all want electrons. Unlike metals, none of them are going to give electrons away, like transfer them. They're all going to want electrons. So they're going to have to share electrons with each other in order to have full valence energy levels and be, like, quote, happy. All right, so let's get started. Our first example here is a hydrofluoric acid. So what we're going to do is go step by step through our method here, and I'm going to try to use different colors for each atom so we can see them a little bit easier. So first step, draw individual atoms with Lewis dot diagrams. Generally put the group 4A or 5A atoms in the center, and hydrogens, which would be in group 1A, or group 7A on the outside. So notice I didn't write really group 1A here, I just wrote hydrogen. That's because hydrogen is the only nonmetal in group 1, so I just wrote a hydrogen there. Okay, so we do have a hydrogen. So it's going to be on the outside. And we have halogen, and that's pretty much it. So we're just going to put them next to each other. And then we need to draw the Lewis dot diagrams around them. So for hydrogen, where it's in group 1A on the periodic table, it's going to have 1 dot. And fluorine, since it's a halogen in group 7, it's going to have 7 valence electrons. So 3 sides with 2 each and then 1 on the last. All right, and I'm going to make a thicker pencil here. Okay, now, next step, we're going to make pairs of shared electrons until every atom is connected in a group and happy. So here, we know that hydrogen is in period 1. That means it has 1 energy level, and it needs 2 electrons to fill that first energy level and be happy. So it would need 1 electron shared with it, and it's going to just demand that fluorine share this electron, or an electron. And fluorine, also very electronegative, it has 7 out of the 8 valence electrons it needs, and so it's going to need 1 shared back. So we can make both of these atoms happy if we simply force them to share a pair of electrons. So let's see, I'm going to use the color black here to kind of pair up my electrons. So I kind of like pair my lonely electrons together. All right, so now my hydrogen is happy. It has access to 2 electrons. And fluorine is happy because it has access to 8 valence electrons. Okay, so now we'll redraw our final version. We're going to start with our atoms. So redrawing our final version, starting with the atoms, we'll do hydrogen there and fluorine next to it. Next, we're going to draw in our lines, which is our shared electrons. So each line will represent 1 pair of shared electrons, and I see that I've drawn 1 line to represent 1 pair. So I'm just going to have 1 line connecting them. And then my last step is to draw in the unshared electron dots. And I should add, we should draw them on the outside. So here are 3 electrons. They're kind of already on the outside, so this will be pretty easy. They're just going to stay in the same place. Okay, like that, and we're done. All right, let's do the next one. We've got carbon and sulfur, both nonmetals. So let's follow our directions. We're going to start with the individual atoms in their Lewis dot diagrams, putting the group 4 or 5 atom in the center. And I do, in fact, have a group 4 atom this time, and we're going to put it in the center. So we will start with carbon. And we're going to put carbon in the center. Sorry, it's hard to juggle all the colors. And then we're going to do the sulfurs on the outside, like that. And now for our Lewis dot diagrams. Carbon's in group 4, and I'm going to do the Lewis dot diagrams like correctly. We start at the top, and then we go clockwise around. And then for sulfur, it's in group 6. So we're going to start clockwise and go around. right, now we need to draw our lonely electrons as shared pairs, basically until everybody is happy. So I see a lonely electron here, and I'm going to pair it up. Another one here, we're going to pair it up. Another one I see here, we'll pair them up. That one there, we'll pair it up. So in this way, carbon might have started with 4 valence electrons, but it's getting another 2 electrons shared with it from the sulfur here. And it's also getting 2 shared with it from the sulfur on this side. And each of the sulfur started with 6 valence electrons, but they're getting 2 electrons shared by the carbon. And so in that way, each atom now has access to 8 valence electrons, and so we would count them as happy. All right, so let's redraw here. All right, we'll start with our atoms, so carbon in the middle, and then our sulfurs on the outside. And then we need to draw our lines. Notice this time I have 2 lines connecting my carbon and my sulfur. So I'm going to need not a single bond, but a double bond. And same thing on the other side. 2 lines, so that's a double covalent bond. All right, next we're going to draw in the unshared electron dots. So looking at carbon, all of its electrons are being shared. It has no unshared electron dots left over. So there's going to be no red dots around this carbon, just lines. Sulfur, on the other hand, it looks like it has 4 dots. It has 4 electrons that it is not sharing with carbon. So we're going to put those on the outside. And it turns out for this sulfur, they're kind of already there. So we don't really have to do anything. On this sulfur, though, it looks like those dots right there need to move. So we can put our 2 on the top, keeping them there. They're not on the side with carbon, they're on the outside. But these 2, we're going to have to move to the outside. So I'm just going to put them over here. All right, now they're on a side that is not being shared with carbon. Pretty much everything in between the atoms is shared in between them. So we wouldn't want the 2 blue dots right here because it would indicate that they're being shared with carbon, and they're not. Now, do they have to be on the top and the side here? No, you could do the side and the bottom. You could do the top and the bottom. Doesn't really matter as long as they are on the outside. Okay. And those are all set. So just to check, you would make sure that each atom had access to 8 electrons. And again, that line represents a pair of shared electrons, 1 from each atom, like 1 from carbon and 1 from sulfur. So carbon here has access to 8 electrons, and so does sulfur. The 4 that are in these bonds plus the 4 that are not being shared. And true for that sulfur too. Okay, next example. So we've got a phosphorus and then 3 bromines. So we'll start with our atoms, and we're going to put the group 4 or group 5 atom in the center. So in that case, we don't have a group 4 atom, but we do have a group 5. That would be the phosphorus. So we're going to put that in the center. And I'm going to draw it here. I already know that's going to make my drawing awkward, but I'm doing that on purpose just so we have to like fix it later. So let's put our phosphorus there. And then our hydrogens, or group 7 atoms, will be on the outside. Well, we don't have a hydrogen, but we do have a halogen, one of the group 7 elements. So bromine. So we're going to put in our bromines on the outside. Like that. Okay, now we need to do our Lewis dot diagrams. So phosphorus is in group 5. And bromine is in group 7. And I'm just going to do 7 on each of my bromines. So I'm always starting my dots at the top and then going around clockwise. That's the best way to do it so you don't mess up. Okay. Next, I'm going to make pairs of shared electrons until every atom is connected in a group and happy. All right. So I need to find sides, like 2 atoms with a side that have a lonely electron, and then connect them. So how about we connect those ones together, and maybe those ones together, and those ones together. So it looks very messy. That's kind of gross. But we're going to do our final version over here and tidy up all of our lines and reorient everything so it's all correct. All right, so let's do a redraw. Got our phosphorus, and then our 3 bromines. All right, we got our atoms in place. Now we're going to draw our lines. Looks like I've got a single bond going to this bromine and a single bond going to this bromine. So we're going to draw it nice and tidy, a short straight line. And I've got 1 bond going to this bromine. So again, a nice short straight line. All right, and now we need to put in our unshared electron dots, and we're going to put them on the outside. So, drawing our dots here, let's start with the phosphorus. Looks like on my phosphorus atom, I've got 2 red dots here that are not being shared. They are not part of a line. So we're going to do those first. And we're going to put them on the outside to show that they're not being shared with any of the other bromines. So we had to kind of like rotate our phosphorus around a bit. And now we're going to do the dots around our bromines. So it looks like this bromine, the dots are already in the right place. And this one, these 4 dots are in the right place. But we're going to have to take these 2 dots and move them to the outside to show that they are not being shared with the phosphorus here. And these 4 dots are in the right place, but we're going to have to take these 2 blue ones and rotate them to the outside to show that they are not being shared with the phosphorus. And we're done. Okay. So just to check, we would want to make sure that each of these atoms has access to 8 electrons. So we notice our phosphorus here, it's got 3 lines and 2 dots. Each of those lines represents 2 electrons, 1 originally from the phosphorus and 1 originally from the bromine, and they're a shared pair. So there's 2 electrons there, 2 there, and 2 there, and then 2 here, so a total of 8. And each of my bromines has access to the 2 electrons that are in the shared pair, and then the 6 that it's not sharing, so also 8. All right, 2 left. All right, methane. So for methane, we've got a carbon. So doing our Lewis dot diagrams, our group 4 atom is going to be in the middle, so that would be carbon. I always like carbon because it's like C for carbon and also C for center. And then we've got our hydrogens or halogens on the outside. And in this case, we've got hydrogens. We've got 4 of them. So we're going to put them just all around the outside of carbon. All right, now for our Lewis dot diagram, carbon's in group 4. So it's going to have 4 dots. And the hydrogens are in group 1. So they're going to have 1 dot. All right, and now to pair up our lonely electrons. Like that. And redraw. So start with our atoms. Then we'll put in our lines. Looks like I've got 1 line going to that hydrogen. I've got 1 line going to that hydrogen, 1 to that one, and 1 to that one. So look like that. And now our dots. So there are no unshared electrons left over for carbon, so there's not going to be any red dots. And there are no unshared electrons around the hydrogen, so there are not going to be any blue dots either. We're finished. That's it. So the carbon has access to 8 valence electrons, the 4 that it started with, and then 4 that it's getting shared from the 4 hydrogens. And each hydrogen, it only needed 2, remember, just like in our hydrofluoric example over here. So it started with 1 valence electron, and then it's getting a second one that's shared from carbon. So all of our hydrogens are happy as well. All right, let's do one last one, water. All right, so we're going to start with the Lewis dot diagrams of the individual atoms. We're going to put our group 4 or 5 in the center. There isn't one, so skip that. And we're going to put our hydrogens or halogens on the outside. Well, I do have hydrogens, so we know the hydrogens are going to go on the outside. So if the hydrogens are going on the outside, that means oxygen must be going in the middle. So we can just do that. And for drawing the Lewis dot diagram, hydrogens are in group 1. They'll have 1 valence electron. Oxygen is in group 6. It's going to have 6 valence electrons, like that. Okay, and now to connect our lonely electrons into a shared pair, look like that. Okay, and we'll redraw first our atoms. then our lines, and we're going to make them short and straight. So I've got one line connecting my oxygen to my hydrogen, so that's one pair of shared electrons. Same thing here, I've got one pair of shared electrons, so a single line for a single covalent bond. And then we're going to fill in last with our unshared electron dots. Well, there aren't any for hydrogen, so they're done already. Remember, that blue dot is now part of the line, just like this red dot is now part of the line. They're a pair of shared electrons represented by that line. So it looks like I've only got electrons on my oxygen that I need to put in. So we'll do our 4 electrons. And notice I've moved them to the other side. And that's because if I drew them here or here, that would mean that they're being shared with the hydrogens. And they're not. They are unshared electrons. So we're drawing them separately as dots on the outside of our molecule. Okay, and if we were to check, oxygen has access to 8 electrons now, and each of the hydrogens have 2, which is all they need. So that is a wrap.